Okay, so for the MLP, there are two topics remaining, which is very useful in terms of external as well as internal examinations. So one is pipelining. Okay, you can search in the pipelining in the 8086. I will give you the another video for that. But let us talk about this memory management. Okay, so in first questions, it says that draw diagram of 512 into 8 RAM. Now let me tell you that if you just notepad, let me open the notepad. So basic thing is that we have the 16 address lines of 8085. Okay, so if any one address line if we select, then you can say how many address it can uh, able to address. It's a 2, it's a 2 raised to n, that is 2 raised to 1. Okay, if there is a 2 address line is there, then it can address up to 2 raised to 2, that is 4. If 3 address line, 2 raised to 3, 8, likewise. Okay, now let me tell you that if you are asking about 512 into 8. Okay, so what is means how many address line it requires to address 512. Okay, so from that you can calculate. Let us take let's just a minute. Let me go for 4, then it can address up to 16. 5, it can address up to 32, sorry. 6, it can address up to 64. 7, it can address up to 128. 8, then it can address to 56. Yes, yeah. 9, it can address up to 512. So right now we got the answer, so let's go on. In the 10 address line, it can address up to 1k. Okay, 11 address line, it can address up to 2k. 12 address line, it can address up to 4k. 13, it can address up to 8k. And 14, it can address up to 16k, right? 15, it can address up to 32k. And finally 16, it can address up to 64. As you know, we have the 16 address line, so maximum capacity of 8085 microprocessor to address up to 64 kilobytes, right? 64 address, 64,000, something like that. Okay, now in the questions it can ask that 512 RAM memory chip to connect to the microprocessor 805. So we have to draw the diagram for this. Okay, so basically what you have to do is that uh, we required how much? 512 means 9 address line. Okay, so as we can see, let us start from 0000, 0000, and 0000. Okay, there are 16 address line is there. Now we require 9, so how much it is variable? That is 9, that is 0000, that is 4, 0000, that is 8, and 9 address line it requires. So what we will do, we will make it this 1. Okay, then 1111, 1111. Now calculate all the ones: 1 2 3 4 5 6 7 8 and 9. So this is the starting address of whatever the memory address we can say, and this is the ending. So why I have taken 9? Because it requires 9 address lines. Understood what I mean say? If you ask 1k into 8, let us say 1k into 8. Sorry, so how much how many address line requires? That is 10. So what we will do, 4 plus 4, 8, 9, and we will make it this to 1. Understood? So we have right now 512. So what is the starting and address, starting and ending address of the, this is like that. Understood? Now we have to draw the diagram of 512. So let me just go to that 512 into 8 8085 MLP memory diagram. So let me show you that how it works. Okay, let me go to the images, and this is the memory interfacing. Oh, this is not good, this is not also that. Let me just select the proper no, no, no. Okay, this from this you can see it's a 108. Okay, so it's a 8-bit database is there. Fine. So how many address and required? 7-bit address. Let me go here, and 112. As you can see, it's a 7, right? So same way, sorry, it's a 7-bit address. Understood? And if it is 512 into 8, then what will be here? It will be 8-bit address. So this is the block diagram you can write. This is a very good diagram. Yes, this is a too much good diagram to draw in your exams. Understood? So this is all, this is diagram for 128 into 8. Okay, and if you ask is what is the questions 512, then what will be change in this diagram? It will be 512 into 8 and how many? 9. Then it will be here 9-bit address. So that is a diagram for 512 into 8. So I hope you understand this topic. Okay, in the next video we will see the second remaining questions, the draw diagram of 000H2 007F ROM memory connection with 8085. Okay, so I hope you understand this questions. Okay, all the best for your exams. Thank you.